We all look up at the stars, right? And we kind of take for granted that like there are these pinpoints of light that are, just kind of always there. But every now and then, one of those seemingly ordinary stars throws us like a total curveball.
Yeah.
And we're going to dive deep today into one of those curveballs, the story of KIC 8462852, better known as Tabby's Star.
Tabby Star.
So this star hangs out between the constellations of Cygnus and Lyrae, and for a good 4 years or so, it was being watched really, really closely by NASA's Kepler mission.
And Kepler was this incredible space telescope. It was looking for planets beyond our solar system, and it had a pretty straightforward way of doing this. It would just stare at stars and look for these tiny dips in their brightness.
Right.
Because the idea was if a planet passes in front of a star, from our point of view, we call that a transit.
Right.
It's going to block a little bit of that starlight. And those dips, you're going to see them, they should be pretty predictable.
Yeah, like clockwork, right?
Yeah. Exactly like clockwork. You know, how deep they are, how often they happen. And it's a really small dip because you're talking about a small planet passing in front of a giant star.
Right, a tiny little blip.
Yeah, exactly.
But then Tabby's Star, it decided to totally, rewrite the rules of the game.
It threw the rule book right out the window.
Instead of these nice, neat, predictable little dips, Kepler starts seeing these super weird dips in brightness.
Yeah, they were irregular, strangely shaped, and totally unpredictable.
Totally.
Yeah. And when we say dips, we're not talking about like a tiny flicker.
Right.
We're talking like sometimes Tabby Star would lose like 20% of its light.
Wow, 20%? That's huge.
Yeah, to give you a sense of scale, a typical exoplanet transit, you're talking about maybe 1% or even less.
Right.
20% is massive. It's like somebody just took a dimmer switch and just cranked it way down and then cranked it back up again.
Yeah, and not only was it the depth of those dips and the brightness that was so weird, but it was also like how long they lasted and the fact that there was absolutely no pattern to them, right?
Yeah.
Like these dips could last anywhere from 5 days to a whopping 80 days.
Yeah, that's a long time.
Yeah, that's a long time compared to hours or maybe a couple days for a normal planet transit.
Exactly.
And like you said, there was no pattern. It was like somebody was playing with a cosmic dimmer switch.
Yeah, it was totally random.
Just randomly.
So here you have this star, right, that seems pretty normal.
Right.
And when scientists first looked at it, they were like, yeah, this is a main sequence F-type star,
Right.
kind of like our sun, just a bit hotter.
Yeah.
But it's doing something that we've never seen before, and it's that dimming that really makes Tabby Star so mysterious,
Right. Like what is out there that could cause a star to act this way? And that's where things start to get a little, mind-blowing, because when you're faced with something this weird and you've never seen it before, people naturally start coming up with some pretty unconventional explanations.
Yeah.
And one of the ideas that got everyone talking, and it was definitely the most sensational idea, was the Alien Megastructure Hypothesis.
Oh, yeah.
Like, what if, what if there's this super advanced alien civilization out there and they've built this giant structure around the star? Yeah.
Yeah.
And that's what's blocking the light.
Yeah. It's amazing that it even came up in scientific discussions, right?
I know.
That's how crazy the observations were. But, scientists at the same time, they were also looking into more normal explanations as well.
Right.
Like maybe there's something wrong with the telescope, or maybe there's something weird going on with the star itself.
Right.
Or maybe there's something orbiting the star that's not a planet like we usually think of.
Right.
So yeah, they were really pushing the boundaries of what we thought was possible.
Yeah. So to figure this all out, scientists, they launched a ton of investigations. Like they started using high-resolution spectroscopy, which is basically like taking the starlight and splitting it apart into all its different colors to see, what the star is made of.
Right.
And how those elements are moving.
Yeah, and they used spectral energy distribution fitting, which is a fancy way of saying.
Okay.
They looked at the star's brightness across the entire electromagnetic spectrum, not just the visible light.
Right.
To figure out its temperature and its energy output.
And they even used high-resolution imaging to look for any other stars that might be messing with Tabby's star.
Yeah, because sometimes stars come in pairs or groups and they can influence each other.
Right.
They also measured the radial velocity of the star, which is basically looking for tiny wobbles in its motion.
Okay.
That could be caused by the gravity of something we can't see.
Right, like a planet or something.
Right.
Exactly. So basically they're doing everything they could to figure out if these dips in brightness were actually real and not just like some kind of glitch.
Yeah, that was the first thing they had to rule out, was the telescope.
Right.
And then once they were sure it was real, they started trying to narrow down the possible causes.
Right.
And that's what we really want to dive deep into today. How unusual Tabby Star's dimming was, and why an alien megastructure even became a serious topic of discussion.
Right.
It shows that sometimes when we find something totally new in the universe, we have to consider even the craziest ideas.
Yeah, alongside the more normal ones.
Exactly.
Okay, so let's break this down. So we have the star, KIC 846-2852, just a normal F-type star, a little hotter than our sun,
Right.
hanging out in space. And Kepler's watching it, expecting to see, the regular little dips in light from planets passing by.
Right, regular transits, like we see all the time.
But that's not what Kepler saw. Instead, it saw these huge, irregular, totally random drops in brightness. We're talking like the star's light decreasing by as much as 20% and lasting for days or weeks.
Yeah, and there was no pattern to it at all. It wasn't like a planet orbiting every few days or every few months. It was just random.
So random, it wasn't like a typical variable star either, right?
No variable stars change their brightness too.
Right.
But they usually do it in a predictable way, or they have certain features in their light that tell us what kind of variable star they are.
Okay.
And Tabby Star didn't match any of those.
So scientists thought, okay, maybe it's not the star itself, maybe it's something outside the star blocking its light.
Yeah, an extrinsic phenomenon.
Right, an extrinsic phenomenon. So they looked really closely, and they found a small companion star kind of far away from Tabby Star.
Right.
And they thought, well, maybe that's causing the dimming. But when they did the calculations, it just didn't work out.
Yeah, the companion star was too faint and too far away to cause those huge 20% dips.
Right.
It could only cause a few percent dimming at most.
Okay, what about dust? Could it be like a dust cloud or something?
That's a good question because, young stars often have these disks of dust and gas around them.
Right.
And sometimes clumps of that dust can block the starlight.
Yeah.
But Tabby Star didn't fit that picture either.
Okay.
Most dusty stars, they usually give off a lot of infrared light, because the dust gets heated up by the star.
Right.
But Tabby Star didn't have that much infrared light.
Interesting.
Plus, young stars with dusty disks, they usually have material falling onto them, as the disk is forming.
Okay.
And we didn't see that with Tabby Star either.
So it didn't fit the profile of a young star with a dusty disk.
Not really.
Okay, so that rules out a lot of things.
Yeah, and here's the thing. To block 20% of a star's light for days or weeks,
Yeah.
you need a lot of material.
Right, like a ton.
Yeah, like a really, really big object or a whole bunch of objects.
And the fact that there was no pattern to the dimming, that also made things even weirder.
Yeah, it basically ruled out a single solid object, like a planet orbiting the star.
Because you'd expect to see those dips happening regularly.
Exactly. If it was a planet on a nice circular orbit,
Right.
you'd see a dip every time it went around the star.
But that wasn't happening.
Nope, it was totally random.
So that means it had to be something more complicated.
Yeah, like maybe a fragmented object or a swarm of objects or even multiple different things all happening at different times.
Right, so basically scientists had ruled out all the usual suspects.
Yeah, all the normal explanations didn't work.
And they were left with this star that was acting totally bizarrely.
Yeah, it was a real head scratcher.
And that's when they started thinking about more unconventional ideas.
Yeah, they had to think outside the box.
Like aliens.
Well, yeah, the Alien Megastructure Hypothesis.
It's a pretty wild idea.
It is, but you can kind of see why people thought of it, right?
I know.
If you imagine this huge artificial structure built around a star,
Yeah.
maybe to collect energy or something.
Right, like a Dyson sphere.
Yeah, like a Dyson sphere.
Right.
As parts of that structure move around, it could block the starlight in these irregular ways.
It's a really cool idea.
It is. It's definitely a cool idea, but it's important to remember that it was just one possibility.
Right.
Scientists were looking at a lot of different explanations, not just aliens.
Right. It was just that the alien one was the one that everyone was talking about.
Yeah, it definitely captured the public's imagination.
Yeah, so to sum up this whole Tabby Star mystery, we have this ordinary looking star doing these extraordinary things.
Yeah, dimming in a way that we'd never seen before.
And when none of the usual explanations worked, scientists had to start thinking about some pretty wild ideas.
Including aliens.
Yeah, and that's what makes Tabby Star so fascinating. It's a reminder that there's still so much out there that we don't understand.
Absolutely.
And even with all our technology and all our knowledge, the universe can still surprise us.
Yeah, it's a humbling thought.
It is. So what do you think, what's the most likely explanation for Tabby Star?
Well, the alien megastructure idea, it's a fun one to think about.
Yeah.
But most scientists now think that the most likely explanation is a swarm of comets, or maybe fragments of planets or something like that.
Okay, so like a whole bunch of debris orbiting the star.
Exactly.
And when that debris passes in front of the star, it causes the dimming.
That's the idea.
That makes sense.
Yeah, it fits the observations pretty well. Because, comets can have these really weird orbits.
Right.
And they can come in all shapes and sizes.
So it could explain why the dimming is so irregular.
Yeah, and it could also explain why we don't see a lot of infrared light, because comets are mostly made of ice and rock.
Right.
Not dust.
But even with that explanation, there are still some things that don't quite add up, right?
Yeah, there are definitely still some challenges. The timing of the dips, the shapes of the dips,
Right.
the overall pattern of the dimming.
It's still a bit of a puzzle.
It is, but that's what makes science so exciting.
Right now.
We're always learning new things and revising our understanding of the universe.
Yeah, it's a never-ending journey.
Exactly.
Yeah.
And Tabby Star is a great example of that.
It really is. So what do you think the future holds for Tabby Star?
Well, I think we're going to keep studying it, using new telescopes and new techniques.
Right.
And hopefully we'll eventually figure out what's really going on.
Yeah, and maybe it'll turn out to be something even weirder than we ever imagined.
You never know.
Well, that's what's so cool about space. There's always the possibility of something totally unexpected.
Exactly. It's a universe full of surprises.
And on that note, I think we'll wrap up our deep dive into Tabby Star.
Sounds good.
But before we go, I want to leave you with one last thought. What does it say about the vastness and the complexity of the universe that even with all our amazing technology, we can still find stars that behave in ways we can't explain?
Yeah, it's a humbling thought.
It really is. It reminds us that there's still so much out there to discover and so much more to learn.
And that's what keeps us exploring.
Exactly. Thanks for joining us on this deep dive into Tabby Star.
My pleasure.
And until next time, keep looking up.